All right, so we've got another example for composition of functions. This time we have x to the fourth and the fourth root of x. So we'll talk first about domain. Right, domain of f of x is going to be all real numbers. For g of x, we are going to be limited to non-negative numbers because we can't take even roots of negative numbers. So what do we have here? We've got f of g of x. So we've got f of fourth root of x. So that means we've got something to the fourth power. We're going to plug in that fourth root. And hey, guess what? X to the fourth power is the same as the 1/4. X to the fourth root, sorry, is the same as 1/4 power. Raised to the fourth. That's just going to be x. However, for this one, technically speaking, the domain is still only positive numbers. So we would have to say x greater than or equal to 0. This is another place where GeoGebra might not give you 100% right as far as the domain goes. All right, so g composed with f, we're looking at g of f of x. So we're looking at the fourth root of x to the fourth, right? I really should probably put this as a, hey, here's what's going in, and we've got to think about that it's going to be x to the fourth. And so we're doing x to the fourth to the 1/4, which again will be equal to x. And now this is a case where these two functions are equal to each other, right? So this is a special case. We're going to talk more about this, I think, in 3.6 about why exactly this happens, but you may have your suspicions because of what you may know about the relationship between x to the fourth and fourth root of x. So domain and composition, of course, we cannot allow any inputs that will result in g of x values that can't be used in f of x. So here, if we look at this and we look at the domain for f of x, we would have to exclude 0, right? For g of x domain, we would have to exclude -1/2 because that would give us a divide by 0. So what about f composed with g, right? So if we do f composed with g, so we're looking at 6 over 1/2x plus 1, right? Now we can simplify that, and that will be 6 times 2x plus 1. So 12x plus 6, that's fine. But we do have input into f of x can't be 0 or undefined. So we'll say that input into f of x can't, well, not that it can't be 0, it can't be undefined. Well, actually for f of x, yes, it can't be 0 either. It can't be equal to 0 or undefined. And this is where GeoGebra may not give you the right answer, okay? So we know that g of x is undefined when x is equal to -1/2. So we have to exclude not only 0, but -1/2 also. All right, so our domain, x can't be -1/2. And we really, yeah, we can't, well, we can include 0 on that one. Well, no, we can't, right? But never, sorry, will g of x ever be equal to 0? Will g of x equals 0 for the output? And if you look at a graph of this, the answer, because it's going to look roughly speaking like this, is no. So we really don't need to worry for this particular case about any places where the output of g of x would cause a divide by 0 error, because it's not going to happen. So for this one, we just need to worry about x not equal to -1/2. What about g composed with f? Right, so g of f of x. So what's our function going to look like there? So we've got 1 over 2 times whatever plus 1, and we're going to put into that empty box, we're going to put 6 over x. Now we can clean this up a little bit. I'm not really going to worry about it right now. So what we can't have, though, is, so we can't have 6 over x be undefined. So we're going to have to throw out 0, but we also can't have f of x equal to, what was it, negative 1/2, right? Because that would cause a divide by 0 error with g of x. So we've got to say, okay, where is 6 over x equal to negative 1/2? And we're going to see pretty quickly that that would happen when x is negative 12. So we've got to throw out two things, negative 12 and 0. So I'll write the domain up here. Domain, x can't be 0, x can't be negative 12. And that's it for that example. So next up is decomposition of functions, and that will be in the next video.